we're asked to consider the graph f and f prime. But what I want you guys to remember is that y is equal to f of x, right? But now y prime is really f prime of x is the slope. Wait, let me rewrite that. If y is equal to f of x, okay, that is, if it were linear, we would think of it as f prime of x times x plus b, if it was a linear relationship. In other words, f prime is the slope of f. Does that make sense? F prime is the slope of f. It's an equation that we use to calculate the slope, but that's what it is. So now what I want to do is, if I sketch the graph of the function f that has the following properties, where f of 0 equals 0, and then graph f prime, the derivative of f, as shown in figure 3.4, f is continuous at all x. So now let's look at this. Here's an interesting thing. Here is f. I'm going to zoom in on f so you guys can look at it and really take a look at it. Now what we have here, what is the slope of f? Could we calculate the slope here from here to here?
Mr. Adams, I think it's a graph right above it.
I know. But my question to you is, could I find the slope from this to here?
Yes.
Yeah. So let's do that. So what I want to do is, this is an absolute value function, right? We know that. And so what we want to do is, we want to consider just this portion. So what is this point right here? 1 comma negative 1, right? What is this point right here? Negative 3 comma 3. Can I calculate the slope of that?
Yes.
What is the slope of that? Yeah, so well, let's calculate it. I'm going to have negative 3 minus 1, right? All over 3 minus 1. So I get negative 2 over 2, which is just negative 1, right? So now if this is f and it has a slope of negative 1 from the interval, what is my lower boundary in the x direction? Negative 3. What is my upper boundary in the x direction? 1. Am I including the 1? Well, it doesn't matter. I guess I could determine what it is when I get to that point. But looky here. This is the graph of f prime. And notice that when I go over the interval, when I go on the interval from negative 3, now here it looks like they decided not to include 1. But what is the slope?
0.
Not the slope of this line. What is the y value of this line? Negative 1. What was the slope right here?
Negative 1.
Does the slope change at all on this?
No.
Does the y value change on this at all? No.
Woo, math. This is the one thing I understand.
Now, let's do this again with the second part of my piecewise function. This is an absolute value function, or something similar to it. What is the interval that I'm concerned with? Well, now I'm concerned with, and we won't include it, and I'll explain why later. Let's not include 1, but we're going from 1 to positive 3. Can I calculate the slope of this? Yes, I can, because this is actually 3 comma 3. And what is the slope of that? it's a positive 2, right? Well, I mean, you could just calculate it, right? If I go up 1, 2 over 1, up 1, 2 over 1. So the slope is positive 2. Does the slope change here at all?
No.
No, it doesn't change at all. So from x equals 1, or close to it, to x equals positive 3, my slope is 2. Because the slope doesn't change here, this graph doesn't change.
Yay. Huh.
Now, just like I said before, if we were to think about this piecewise function, from here to here, we have x raised to the first power. When I look at y prime, we have x raised to the 0 power, right? Because this is a constant.
Why is 1 not included?
Oh, because we can't take a derivative at the cusp. There's a reason. We haven't gone through that formal definition where I tell you why. I will at some point, but just know that when you see a cusp like this, a sharp point, right, that we can't. Well, I don't want to get into all the details right this second. It might, the explanation is longer than we have, and it might confuse you more. What I really want to focus on primarily is that the slope doesn't change here and the slope doesn't change here. So we're trying to establish the relationship between f of x and f prime. Okay? Do you guys get it?
Yep.
Good.